Sairam. Having seen various concepts about adsorption, now let's get into the second aspect of this particular chapter, which is catalysis. Now this word actually you have come across many a times in your study, all through your junior studies at the secondary level and now at the senior secondary level also. So what is this catalysis? What are catalytic properties? In fact, you have come across many catalysts till now. So now let us just see certain characteristics of this, what is the role in the reactions and other aspects. So starting up with this part now, it so happens that if you just bring about hydrogen and oxygen and keep them together, nothing will happen in those cases. For such a reaction to happen, you need somebody who can initiate the reaction. Sometimes reactions keep flowing, but then they would need somebody to just start them at the beginning point. Some reactions need some sort of materials which can keep them in continuity. So mainly here we can see that especially when this hydrogen and oxygen are being present, you need a catalyst like platinum. So what does a platinum do there is, it sees to it that the reaction between those two occurs very readily as such. So this is how, so what are these catalysts? We can call them as those which alter the rate of the reaction. Now why do we use this word alter is because sometimes catalysts can increase the reaction. They can also decrease the speed of the reaction, which we will be studying in further parts. And why do we need this decreasing property also? Because some reactions are very fast. They can be explosive in nature. So if at all you can get some materials or say substances which can reduce the speed of the reaction, that can also be of very good help. So how do we define this set of catalysts here? They are substances which alter the rate of a chemical reaction. They take part in the reaction, but then they remain chemically and quantitatively unchanged. What does this word mean here, quantitatively? Suppose you have taken 5 grams in the reaction. At the end of the reaction, after all the reaction has happened, you will still get back that 5 gram. So did it undergo anything in the entire reaction? Yes. It supported the rate of the reaction, but individually it did not change up into anything. So these type of compounds we call them as catalysts, and this phenomenon we tend to call it as catalysis. Now let us see just some examples of these catalysts. Some of the examples have been just enlisted here. Decomposition. Decomposition indicates breaking down. So potassium chlorate compound is taken, and in the presence of this catalyst, which is manganese oxide, so you get this type of reaction. Suppose there is no catalyst, you will not be able to see this reaction at all. So what you need to know is a couple of examples, and that is why various types of reactions are been shown here. The evolution of hydrogen gas, this is one of the methods of preparation of hydrogen gas. Now here it was a solid catalyst, whereas here aqueous. What does this aqueous indicate? It indicates that some solution of a copper salt. Any copper salt, you can now Cu2 plus indicates you can have CuSO4. This is one copper sulfate. You can also tend to have copper chloride salt in these cases. So any of these salts can be utilized, and you can form this reaction. Similarly, you can see oxidation of hydrochloric acid. Now this is possible when you pass on cupric chloride. Now what is the difference between the catalyst that has been used here and here is that this is specifically a solid cupric chloride which has to be used, whereas here it's in aqueous form, which means that it has been mixed in water, and necessarily it need not be CuCl2 only. Now though this is copper in +2 state, it necessarily need not be that. It can also be copper sulfate also. So that is what we tend to understand, that catalysts are sometimes very specific in nature, sometimes general in nature also. So these are some examples that we come across for catalysts, and now we'll see various types of catalysts. Generally the role of a catalyst is get into a reaction, take part in it, see to it that the reactants get converted to products quickly, and then come out as it is. Now it so happens that some of the compounds, or say some reactions, you need not add a catalyst specially outside, but when the reaction takes place, it forms various products. Now one such example is given here, where potassium permanganate, sulfuric acid and oxalic acid has been used. Now when this reaction is starting, you are not using any catalyst. So this has been started in the initial process by mixing and stirring them very well. So that external energy content that you are giving is good enough for this to react. Now how much time will you keep on stirring? So you need something that so that it can move along on its own pace. So that is possible when these products are formed, and in that especially the manganese sulfate MnSO4 which is formed. If you see the ionic components of MnSO4, we can split it as Mn2 plus and SO4 2 minus. So this Mn2 plus ions which are being formed catalyzes the reaction. So because you are not adding any catalyst from outside, the catalyst is generating in the system itself and then helping the reaction. That is why we call it as auto catalyst. Generally auto indicates happening on its own. You are not supplying anything from outside. So this is one example of auto catalyst where you can see that at room temperature reaction is slow at the beginning because you have just stirred it, but then gradually it becomes fast because there is one of the products generated which can act like a catalytic material, and it is not acting as catalysis in their solid form, but then since it is aqueous, we know very well that in aqua medium, water medium, generally they split into ions, and that ions which has been split Mn2 plus helps in catalyzing this reaction so that over a period of time it becomes pretty much faster. So this is about the auto catalysis. Moving further, negative catalysis. I happen to tell you that generally catalysts are no doubt used to speed up the reaction. At the same time you can also slow down the reaction also, and since slowing down is from a negative point of view, that is why the name comes negative catalysis. So what is this negative catalysis? It retards a reaction rather than speed it up. So basically reaction is happening at a particular pace, but you want to slow it down. That is where you can use this. So some examples, once again they are shown. Glycerol retards the decomposition of hydrogen peroxide, because if hydrogen peroxide is decomposed at a faster pace, it forms unstable products. So that is why slow reaction is expected here. Phenol retards oxidation of sulfurous acid. If it doesn't retard, then sulfurous acid will never be able to get sulfuric acid anytime, because sulfurous acid is H2SO3. So if that pace has been reduced, then we can stabilize that compound, or else sulfuric acid is the general component which we tend to get it. So this is another aspect about catalysis as such, and then promoters and poisons. Now this is an important thing. It could be a little confusing of sorts, because it so happens that generally catalysts we mean that it increases the speed of the reaction, and negative catalysis we mean that it decreases the speed of the reaction. Then what is the role of these substances, promoters and poisons? The substances which increase the activity of a catalyst, these promoters or poisons have nothing to do with the reactants. If there is a reactant system, so A plus B is giving rise to give C plus D. Now if this reaction has to be made faster, then probably we may use a catalyst X. So what is the role of catalyst? That X is seeing to it that A and B react at a faster pace. But you can also improve the activity of the X. You can see to it that X gives a better performance. So there you use something Z. Now what is the role of the Z? Z is not going to do anything for A and B. It is rather going to increase the activity for X. So that is what we see here by definition, that substances which increase the activity of the catalyst we call it as promoters, and those which decrease the activity of the catalyst we call it as poisons. Please be crystal clear that promoters and poisons have nothing to do with the reactants. They are rather helping the catalyst to improve on their performance in their cases. Okay, so some examples, because we have to understand this part very clearly. So first thing is in the Haber's process. We know very well that Haber's process is nothing but production of ammonia, N2 plus 3H2. So in this case, the catalytic activity of iron is enhanced by molybdenum, which indicates that suppose I have this reaction N2 plus 3H2. This is generally a reversible reaction. It gives you 2NH3. This is the reaction which is taking place. Iron is acting as a catalyst. So what is the role of iron? Sees to it that nitrogen and hydrogen are acting in a better pace. So remember, all of them are in gaseous form, all these gases or the reactants and products. Now along with this iron, they also tend to use molybdenum. So what is the role of molybdenum? It sees to it that iron acts as a better catalyst. The activity of iron is improved. Similarly, copper promotes the catalytic activity of nickel during hydrogenation. We are pretty much aware that in hydrogenation reactions, we use the nickel, platinum, palladium as the major reducing agents. So if you want to increase their activity, you can use copper for that. Haber's process, catalyst iron is poisoned by hydrogen sulfide. Now, when you have already used a promoter, why do you want to again use a poison? Supposing if you want to take the reaction slowly, please understand that when I write a reaction N2 plus 3H2, I am showing it as a reversible reaction. I hope you are always pretty much clear with what is a reversible reaction. Goes on either sides. So when I want to prepare ammonia, I would love to see to it that N2 and H2 are reacting strongly and forming NH3. But since it is reversible, some amount of ammonia will also come back to this side, which I would not want. So that is why, what does poison do there? Probably it slows down the reverse reaction. That this reaction is being accelerated by the support of catalyst iron, by the support of molybdenum as a promoter, but reverse reaction is slowly slowed down by the support of hydrogen sulfide. So this is how we tend to use the compounds as promoters and poison. We have another last example here in the contact process. Platinum is poisoned by even traces of arsenic oxide. So platinum is the one which we use it as a catalyst, and if there are arsenic oxides present, generally it will be present because we extract this from Earth's crust, and these type of elements are present in small traces. So if they are present, the reaction will not happen at a faster pace. It will slow down the activity of platinum. So this was about promoters and poisons. So this explains the fundamental aspects of catalysts and all, and then we have to see what are the characteristics of these parts, which we'll be seeing in the next final part of this particular chapter. Thank you. Sai Ram.